In this lecture, we're going to thoroughly investigate lines in the Cartesian plane. And if I have any two distinct points in the Cartesian plane, this completely determines a line. For example, on this page, if I draw any 2 points, then there's a unique line passing through those 2 points, and I can construct it by taking a straight edge and joining the 2 points with the straight edge and then extending along the straight edge. And then, of course, this goes on in both directions, and that's the unique straight line passing through those points. The slope of any particular line is the change in the vertical distance between 2 points, any 2 points, divided by the change in the horizontal distance between the 2 points. And for a straight line, this is a constant. No matter what 2 points I take, I get the same answer for this calculation of the slope. Why is that true? Well, suppose I take 2 points on this straight line. Then I have the vertical distance here. This point is x2 prime, y2 prime. This one is x1 prime, y1 prime. The change in vertical distance between the 2 points is the difference in the y values, y2 prime minus y1 prime. If I divide that by x2 prime minus x1 prime, I get the quotient of the lengths of the edges, these 2 edges of this right-angled triangle. If I take any other 2 points and I do the same calculation, I take the length of this edge divided by the length of this edge, then I should get the same answer because these are similar triangles. Both are right-angled triangles, and because they're on the same straight line, these angles are equal. Sorry, that angle is equal to this one, and that angle is equal to this one. So hence, no matter which 2 points I choose to calculate the slope, I should get the same answer. So suppose I have 2 points. I know there's a unique line that runs through these 2 points. What's the slope of that line? Well, I don't need to draw the line in order to calculate the slope. I'm going to call this line x1, y1, x2, y2. Doesn't matter which one I choose to be x1 and y1, or x2 and y2. And then I apply the formula. M is equal to y2 minus y1 over x2 minus x1. Now, it is important that I maintain the order of the y's and the x's, so this should be y2 minus y1 over x2 minus x1. I can't mix up the x's here in the denominator. So this is equal to 1 minus 2 over 4 minus 1, and that's equal to minus 1 over 3, and that's the slope of this line. It's a negative number, and no matter what 2 points I pick on that line, the slope is going to turn out to be this number. You should try this, of course, and then check to see if you have the answer correct. The slope of the line that runs through these points, I label the 2 points, x1, y1 and x2, y2. Then I write down my formula. And the rest are details. I fill in the details. Minus 5, minus 1, over minus 3, minus 0. That's minus 6 over minus 3. Those negatives cancel, and that's a 2. So this one has a positive slope of 2. There's another way to construct a line. If you're given a point and a slope, then there's a unique line passing through the point with that particular slope. So if I take a point on the plane and I'm looking for a line that passes through this with, say, slope 2, then I should have a unit of measurement, and for every 1 unit across, this line is going to increase vertically by 2 units. So that gives me a direction for the line. And then I can just extend that with a straight edge to get the unique straight line through this point P with slope M. Lines which have a positive slope slant upwards. If I were to climb the line from left to right with my backpack, if it has a positive slope, then I'm going uphill as I go from left to right. If the line has a negative slope and I'm walking along it from left to right, oops, that looks a little strange. I'm heading in this direction, then if it has a negative slope, this one has a slope of -1/2, then I should be going downhill. If it has a 0 slope, then the line is horizontal. And the hiking is easy. There's neither an incline nor a decline in the terrain. It's just simply horizontal terrain. So positive slopes mean the line is moving upwards from left to right. Negative slopes, the line is moving downwards from left to right. And 0 slope, it's a horizontal line.